Okay. And then I need to share. Right, let's go, guys. Right. Okay, let's go, please. Yes. Yeah. Yeah. All right. Can we do that too? I don't know. Maybe let's do it. Right. Alright. So, ready to draw that, please? No. Okay. So, guys, remember, the graphs are in many ways the same as other graphs. If you had a parabola and you had, like, you were drawing the graph y is equal, you're being recorded, by the way. Okay, and I've drawn the graph y is equal to x squared. Okay. What's the job of a function? It links up your x and y coordinates, right? So on this graph, if you put x is equal to 2, the y coordinate would be what? 2 squared, which is 4. You will agree with that. Okay, if x is minus 3, y would be 9. So it links up every x coordinate with every y coordinate, with the y coordinate that goes with it. Okay, that's what a function is, right? So then, because there's so many points, essentially a graph is made of an infinite number of points, right? Okay, each of those points on the graph has a coordinate, right? So now what we're simply doing is you've got a trig function, okay, like you've got a function sine of theta. And what's going, remember these machines that you did? Okay, so if you had this x squared machine, you'd put 2 in and what would come out? 4, right? So 2, 4 would be a point on the graph. Now you're putting an angle into the function. And at the angle, okay, what goes on the x-axis is an angle. Okay, don't get confused with, we can represent trig like this, where the angle is not a point, the angle is what we measure. Here the angle is measured on the Cartesian plane, if we have x and y axis. Okay, there the angle is an actual measurement, and we get an x, y, and r that go with it, the ratio. Using sine is equal to y over r. Okay, what's the ratios? Shay? Y? So x raised 10. So that links up all of those things, that diagram over there, right? Okay. But now, so here the angle is measured when you're working on the Cartesian plane. Here, in this trig graph, angles are x coordinates. You with me? But now, angles are not measured in an anti-clockwise direction. Angles are your x coordinates. So you put an angle in. So if I put an angle of 90 degrees, get your calculators out. Okay, make sure they're on degree mode. Okay, and go sine 90. Oh, so where's your calculator? Okay, right, come on. Okay, so go sine 90, and what do you get as your answer? So if you put in 90, you get an answer out of 1. What does that mean? On this graph, on the graph y is equal to sine theta, what's the coordinate? And its x coordinate is 90 degrees. Sine of 90 degrees is 1. You with me? Okay. So I'm just going to show you something. Okay, I'm just going to scribble. Okay, you don't have to write this down if you don't want to. Okay, but just to show you how the things link up. Okay, just briefly. Okay, don't let me go on time 5 minutes in it. I don't want to go on more than 5 minutes with this. So let's just say we take the function. Okay, y is equal to sine theta. Okay, you don't have to write this on if you don't want. Okay, if I want to show you what's going on the Cartesian plane, as opposed to a trig graph and how they compare. Okay, I'm just going to do this with one of these things. Okay, so Cartesian plane, what are axes? X and Y. Okay, on a trig graph, I'm going to draw it between 0 and 360. Okay, here I'm going to put theta on this axis. Okay, and I'm going to put Y on that axis over there, right? Okay, so, and I'm going to measure on this axis is going to be angles. I'm just going to look at these 4 angles. Okay, so if I look at 90 degrees, first of all. Okay, if I look at 90 degrees, okay, we just said, let's start with 0 actually. Okay, what's sine of 0 degrees? You tell me on your calculator. What's sine of 0 degrees? Okay, sine of 0 degrees is 0. Okay, how do I represent this information on this graph? Well, it means once I've traveled through 0 degrees, so I'm somewhere on this line, right? Then the ratio of y over r is equal to 0. So what must the y coordinate be? 0. Okay, I'm going to work with a circle of radius 2. It could be anything. Okay, so 2, 0 would be a point in the graph, right? Because sine of 0 is 0 if my radius was 2. On this graph, well, we know sine of 0 is 0. What does that mean on this graph? Now we think of a graph, right? X and Y coordinates. What am I putting into the graph? 0 degrees. What's sine of 0 degrees? 0. So where's 0 degrees 0? It's over here, right? Okay. If I now look at 90 degrees, we just looked on your calculator, sine of 90 degrees is equal to 1, right? I'm just saying I randomly picked a radius of 2 because it works nicely. So if sine of 90 degrees is 1, what's y over r going to be?
2.
Come on. What's y over r going to be? Y must be equal to 2, right? Okay. So how would I represent this on this graph? When I've traveled through 90 degrees, what do I know? The y coordinate and the radius are the same. So what's the coordinate of this point over here? Okay, x is what? What's the x coordinate? The x coordinate here. It's the x coordinate is 0. Got nothing across, right? But the y doesn't matter. The y and the radius are both what? 2, right? So this is a point 0, 2. That in blue illustrates the fact on this graph, sine of 90 degrees is equal to 1. I've traveled through 90 degrees. I've got a y value 1 there. Right. Okay. On this graph, what have I got? Well, because sine of 90 is equal to 1, Taylor, what does it mean? What's the coordinate on this graph? 90 and 1, which is, if I go 1 up, 91 is a point on that graph. So here's that point, the fact that sine of 90 is equal to 1 on this representation. Sine of 90 is equal to 1 here means if I travel through 90 degrees, my y coordinates and my radius are the same. But tell me what sine of 180 is. Use your calculator. What's sine of 180? Okay, everyone. Sine of 180 is 0, right? What does that mean on this graph? When I've traveled through 180 degrees, when I've traveled through 180, here's 180, right? If I've traveled through 180 degrees, what's the y coordinate?
0.
Okay, y coordinate is 0, right? So where's that point? It's over here. What's the coordinates of that point? -2, 0. Why? Because 0, okay, divided by 2 is equal to 0, right? On this graph, what does it mean that sine 180 is equal to 0? The coordinate is 180, 0. Where is that? It's over there, right? The fish. Okay, 2 more. Okay, if I said to you sine of 270, go look in your calculator. What's sine of 270? It's -1. What does that mean y over r is equal to? R is 2. What must y be? So the y coordinate must be -2, right? Where is that? That's over here. Okay, so what's the coordinate to this point? 0, -2, right? Then I've traveled through, this was an angle in green of 180. This is an angle of 270. But here on this representation, what's sine of 270? Okay, sine of 270 is equal to -1. What does that mean? What's the coordinate of a point in this graph? 270 -1, okay, which is somewhere. There's 270 -1, right? Yeah. So I'm ignoring you, sorry. Okay, right. What have you learned? Men can't be trusted, Nene. Right. Nene, what's sine of 360? Go tell me in your calculator. You have a secret life, Nene, where you go out clubbing somewhere? Because yesterday, first lesson, you were fresh as a daisy. Now, first lesson, but last night a clubbing night. What was this? Maybe you shouldn't sleep. Maybe you should go out rather. Right. Okay. Sine of 360 is what does that mean? Y over R is 0 over 2. Okay. So sine of 360 is 0. Okay. So 360, you're back at naught, right? Okay. Then you travel all the way through 360 degrees, right? But on this graph, okay, the fact that sine of 360 is equal to 0, okay, means what? What's the point on this graph? 360, 0. You see the difference between the two representations? Okay, I'm still going to make up a question where I link these two things up somehow. Okay, right. And then that's how we get. And then our trig graph. Because I promise you, if you worked out 30, you'll get a y value there, 60, 30, etc. Okay, all of those points forms a smooth curve, right? And believe it or not, trig graphs actually do describe quite a lot of things in the natural world. Okay, so a lot of physics. Okay. Oscillation of waves, all your wave properties are really related to trig graphs. Okay, right. So now, just out of interest, on this diagram, okay, remember this? All students take cocaine, right? What does that tell you? Listen, so stay with me. It tells us where the trig functions are positive. So what does it say? Between 0 and 90, all trig functions are positive. If we look at this sine graph, y graph being positive, it means the y coordinate, what comes out is positive, right? Are your y coordinates positive in that region? So that's quadrant 1 between 0 and 90, and they're all positive, right? We then expect sine to be in this quadrant. What do we expect sine to be? Positive. So in other words, between 9, this is quadrant 2, right? In quadrant 2, are your y coordinates positive? Okay, right? So that was all students. Okay, in quadrant 3, okay, we only expect tan to be positive. So what do we expect of sine? Negative. That it's going to be negative. Quadrant 3 is between 180 and 270, and your y coordinates are negative, right? And in quadrant 4, what I expect it to be negative again, because only cos is negative, and here it's below the x-axis. The y function we say is negative, right? So that's quadrant 4. It's negative. So all students talk crap. It's only positive in 1 and 2. They're not separate ideas, okay? But we kind of work with them always separately. Okay, just to show you quickly from this graph. Okay, then I'm going to give you another 2-minute break. Okay, right. If I gave you now I've got these points. I've got 2, 0, 0, 2, negative 2, 0, 0, negative 2, without using your calculator. Okay, depends down if you want to for a second. Okay, go tell me first of all, without using your calculator, using this diagram. Okay. Okay, what is cos of 0 degrees? Speak to your neighbors. No, we don't have to. Okay, what you're using shave your rear, right? So in other words, cos is equal to the x coordinate over the radius for a particular angle. So speak to your neighbor and tell me what cos of 0 is. If I see you using your calculator, I'm going to throw it into his door. Use the fact that cos is the x coordinate, the ratio of the x coordinate to the radius. On this diagram, I mean, what's the x coordinate at 0 degrees? At 0 degrees, if I'm working with a radius of 2, the x coordinate must be 2, right? And what's the radius everywhere? Your radius everywhere is 2. It's going to be 2 over 2, which is 1, right? So cos of 0 degrees is equal to 1, right? So if I'm drawing a cos graph, did I have that somewhere over here? If I'm drawing a cos graph, sorry, I'm going to have to make that smaller. What's the coordinates? If cos of 0 is 2, sorry, cos of 0 degrees is 1, what's the point? 0, 1, right? Which is over here, right? Okay, using this diagram, go tell me what cos, ask your neighbor and you figure out what is cos of 90. Well, come on, you've got to engage, guys. Okay, cos of 90 is x over r. So go look at your diagram. at 90, when you've traveled through 90 degrees. Okay. What's the x coordinate going to be, Marissa?
So,
If I've traveled through 90 degrees,
yes.
what's the x coordinate? X coordinate.
I mean 0.
Okay, so cos of 90, when you travel through 90, the x coordinate is 0, the radius is 6 plus 2. So what's cos of 90 equal to? 0. So what's a point on this graph? What's the point on this graph? No, when you put in an angle of 90 degrees, what comes out? A ratio of 0. So there's another point. Okay, 90, 0. Okay, which is over here. Okay, so there's another, so I've got 2 points. Use this graph and go work out with your neighbor what's cos of 180. Cos of 180, which point are you working with? You've traveled through 180, you're working with that point. So I can check, what's cos of 180 going to be? At 180, what's your x coordinate? Guys, sitting here passively doesn't help you. Okay, cos of 180 is going to be what? What's cos equal to? The ratio of the x coordinate over the radius in the Cartesian plane. What's the x coordinate? -2. What's the radius? So what's that telling us in this graph? If cos of 180 is -1, what's the point coordinates of a point on the graph? When I put in 180, what I get out? -1. Where is that? 180 across, -1 down is over there, right? Okay. Go to 270. 2 more points in level break.
Yeah.
So, at 270, what's my x coordinate? 0. No, your x coordinate is 0. Okay, right. But you've got nothing across, so it must be 0. So it's 0/2, which is 0, right? So on this graph, cos of 270 is equal to what? It's equal to 0. So what's the point? Where is that? It's over there, right? Go to the last one. 360 is the same as 0. This is the point 20. Okay. So,
Yeah.
sine of 0 is y of r, so it was 0/2. But now it's cos of 360. So that's 0.20, right? Okay. So what's cos of 360 going to be? X over r, which is 2/2, which is equal to what? So 361 is another point in this graph. Where is that? Over here, right? So this is what your graph of cos looks like. Okay. And if we look at the quadrants, all students talk crap. What do we expect? Expect the y coordinates in quadrant 1 of a cos graph to be positive, right? Because they're all positive in quadrant 1. Where's quadrant 1? Between 0 and are your y coordinates positive there? Yes, they are. In quadrant 2, what do we expect? We expect them to be negative, right? The y coordinates to be negative. Okay, quadrant 2 is between 90 and 180. Are the y coordinates in that quadrant negative? Yes, because we expected all to be positive here, but only sine to be positive there. Okay, in quadrant 3, what do you expect? We expect it to be negative. Why? Because only tan we can predict is going to be positive there. So in this quadrant 3, okay, tan is, we expect cos to be negative, right? And in quadrant 4, what do we expect to happen to cos? Positive, right? Where's quadrant 4? Between 270 and 360. Okay, and as you can see, your y coordinates there are positive. Okay, because all students talk crap. Right, you're on 2-minute break because that was quite a lot. That shows you a bit of the link. I'm never going to talk about that again much.
So when I was job shadowing, one of the middle grade ones asked me why you can't take 19 away from 1. And I really couldn't tell her that it was into a negative. And I just confused her life. So I was just, imagine you have 1 apple. Can you take 19 apples away from? No. Can you take 1 apple away from 19? Yeah. So which is the right answer? 19 away from 1? Yeah.
No, just ruin all of that. Right. Okay.
I would have thought you'd been lied to her whole life.
Yes.
So that's so cool. Yeah. We're gonna have to do that one day. But I think all the questions are actually going to be enough.
Yeah.
I think one generation.
Yeah, well, post it today, guys.
Posted like some chick was in her gym. Yeah, so then she said, like talent lady, that's what she has to say. I laughed because some chick became so you
Alright.
all the ladies.
One more minute.
So his
Real.
kids
What do you think about Ola?
they can go in any class. No one is around, so they want to. Yeah.
I like the leotards. I just watched gymnastics with red leotards.
You know, it's
At least it's not like a leotard business.
I don't think because.
Usually often.
Parent answer like this.
What's your name again?
Yeah.
Tatiana. Other lady makes a part of the maternity as well. To the restaurant. And then one of the guys makes a part of turn back. Okay. All right. So now, guys, so we've done all of that and given you some understanding. Now we're going to go to how the hell do we actually just go draw these things, right? Okay, and the quickest way to draw them. So get your calculator. Okay. So you're going to need one of those sort of calculators with the white calculator too. Okay. All right. So try and bring a share right now. Okay. Why aren't you using the silver calculator, Marissa? Okay. Right. So now, okay. On your the way we're going to sketch these is this. So we want to sketch the graph f of x is equal to sine x. Okay. All that means is we're putting in x values. Okay. And we get sine x out. Right? Your y values are sine of whatever that angle is. X is in this case, x is an angle, right? If we're using this notation. We could have talked about sine theta, but now we're talking about so in this case, x is an angle, right? So on your calculator, if I want to draw this graph, f of x is equal to sine x. Okay, go to your calculator, right? Okay, and you're going to do this. Okay, go to table mode. So go mode table. Come on. Nabia, let's get with it. Come on. Okay, go to your calculator. Right, you've done it. Okay, then I apologize. Right, so go. That must have been Nabia's superpower. Right, okay. So if I go sine of, so you're going to go enter the equation. So you're going to go f of x is equal to, then you're going to press sine, then you press alpha x, right? Have you all got that? So it should say f of x is equal to sine x on your calculator.
Bracket.
You press the red button. You got it? Okay, now you press equals. Okay, and g of x will kind of come up. You ignore that. We're not drawing two graphs. We're just drawing one. Okay, so just press equals again, right? Now, the start. The start is, they tell you where the start is in the question. Because trig graphs go on forever. Okay, you could put in an angle of 52 million degrees. Okay, we obviously can't draw that. So they give us the domain value. This is the domain of the graph. Whatever that is the domain. It's saying draw the graph for x values for angles between 0 and 360. Okay, we don't want negative angles. Okay, we only want angles between 0 and 360. So in this case, the start is, on your calculator, is 0. So you go start 0. Okay. And then the end is going to be? Okay, so start is 0. End is going to be 360. Now your step, okay, for now, it's always going to be 90 degrees. I'm going to show you it's going to change. Right? Then you press equal. Right? Then your table will spit out points. Okay, so it spits out. Okay, step is 90. Okay, right? So, what's the first point it gives you? 0, 0, right? Then 91, right? I'm going to label that. Okay, then 180, 0. Okay, then 270. -1, then 360, right? So go through those 4 points, right? When you join it up, if you join up the rule, I'm taking off a mark. Okay. It flattens out towards the top. Okay. And flattens out down here. And there's my graph. Okay. So this is the graph of f of x is equal to sine x. Okay. Now I'm going to do one more. Go to 2 sine x now. Okay. You actually can do it without the calculator fairly easy. Okay, but just do it in the calculator once just to check you get in the calculator table mode right. So now when you enter the equation, you're going to enter. Okay. So that was f of x is equal to sine x. Now we're going to do g of x is 2 sine x. When you calculate, make sure you get the calculator right. Mode, table, okay. The function f of x is 2 sine x. G of x, you press nothing. Your start is 0. Your end is 360. Your step is 90. This gets a bit confusing, I think. Okay. Right. So then I end up with 90 degrees, 2, and 180, 0, and 270, -2, right? And 360, 0. So what's happening, if we say, is that the amplitude of the graph is increasing. Okay. In science, I always think of trig graphs as if you took a rope, 2 people holding a rope, 1 person still. Okay. And you do this, right? Okay. You put energy into that wave. How big the shake is, okay, how much energy you put into that, not how often, okay, determines how much the rope is going to go up. If you just go like that, like a 90 little one, it's not going to be, the wave isn't going to distort much. But if you do that, okay, you're going to get a bigger thing. What's that thing called? That distance from the flat line to the top and the bottom. The amplitude of the graph, right? This distance, okay, over here is the amplitude. That distance over there, amplitude can't be negative. Okay, it's a distance, right? Okay, so but the graph, sorry, 1 second, of 2 sine x then is going to, what's happened to compared to the graph of g? The amplitude has increased. Instead of being 1, okay, now the amplitude is 2. That distance is 2, right? There's more energy in that wave. Okay, right, so that's 2 sine x, so that's g of x is equal to 2 sine x. And what do we expect? So what's happening, guys, on the original graph? When x was 90, y was 1, right? That was on the graph of sine x. Here, when x is 90, y is 2. What's happening to every y coordinate when you do go from sine x to 2 sine x? You're timesing the y coordinates by 2. Every y coordinate is 2 times what it was before. So 1 times 2 is 2. But 0 times 2 is still just 0, right? -1 times 2 is -2, right? And 0 times 2 is still just 0. So go draw 3 sine x without using a calculator now. Go draw 3 sine x without using a calculator. Okay, based on what sine x is. So what when I'm drawing 3 sine x, simple. What am I doing compared to sine x? What am I doing to the y coordinates to get from sine x to 3? You're timesing them by 3. So it was 1. So what's it going to become now? But 0 times 3 is still, therefore do this with me in your head, 0. It was 1 on sine, so 3 sine x, 1 times 3 is going to be 0 times 3 is still -1 times 3 is, and 0 times 3. So this is going to be the graph of h of x is equal to 3 sine x. So this number in front, guys, it's affecting what of the graph? Okay, it's affecting the amplitude of the graph and the range of the graph. Okay, so go on to the questions underneath. Right, to answer those questions, speak to your neighbor. Yeah. Draw it in. No, it's only I'm just explaining. Okay. You don't have to, where I illustrated the amplitude, you don't have to draw it in. Just remember, amplitude can't be negative.
So what would the range be? And would it be y?
Of y value, y is an element of, so the red one is negative 1 to 1. The lowest, smallest y coordinate is negative 1, the biggest y coordinate is 1. The blue one would be negative 2 to 2.
One, two,
Now, keep in mind your parents. I've had a couple of parents where I've been doing online meetings, straight into my classroom saying, where's parents' evening? Parents' evening is online. They must not come to school. Okay. I've had a couple of parents who've been online in the parking lot at school. Okay. So please remind your parents if they are coming to parents' evening, it is online. Okay. If you live at home, you're welcome to join them on the meeting. Okay. In fact, it's probably more constructive. Or if your parents want you there, if they don't want you there, that's But if you actually completely right. Yes. Awards assembly next Wednesday. Yours is the second one. So yours is from 5 to I think it starts at 5, doesn't it?
Don't they say 6 to 8?
I can't remember. I'll check. I'll be 6, I don't know. Well, not go around your dance schedule. Okay, right. The parents can come. All right. Okay. So for F, yes. Okay. Right. What's the amplitude, Nene, of the red graph? Right. So the amplitude is equal to 1. Right? The distance there is 1. Okay. Dear, what's the amplitude of the blue graph? Okay. Right, because the distance of displacement is 2. Okay. And Peter, what's the amplitude of the green graph? Okay. So your amplitude, okay, it has to be positive, okay, first of all, right? And the distance of displacement from when the rope was flat to when it reached the maximum after you put energy in, okay, where it gets to. Okay. Any questions about that? The domains are all the same for all 3 graphs. And in a trig graph question, they always give you the domain in the question. Here was my domain. For all of them, I'm drawing the graph. X is an element of 0, 360. So your domain is fixed. It's told. If you get the domain wrong, hey, you owe me a house. Okay, so domain for all 3 is X goes from 0 to 360. I did. Okay. Now, so the amplitude of F was 1. The amplitude of G. What effect does, sorry, A have on the graph? Sorry, it changes the amplitude and range. Sorry. Changes amplitude and range. Thank you. What does range mean on any function, whether it's algebra graphs or trig graphs? It's all the possible y coordinates, how far you go up and down. So all 3 ranges are going to be different.
Yeah, good. Oh, no. You did the. Yeah.
What's wrong with your taking? I mean, it was Burpee.
Oh, please, yes.
All right. So the range of F, please here. Y is an element of?
-1 to 1.
Good. If you prefer inequalities, you could say, no, I'm not going to do that. Okay. Right. So your y coordinates, your biggest y coordinate is 1. It's the graph exists between -1 and -1, right? Okay, always put them. 1 -1 is wrong. The more -1 has to be on the left, the more positive one on the right. Okay. So what's the range of the blue graph of G? You look like you're about to drift into a coma. Be careful. Right. Y goes from negative to 2. Okay. All right. And Sophie, the range of the green grass. Lovely stuff. All right, guys. Well done.
Anything.
We need another day.
Oh, bless. Why did it take you so long to do?
Then and now, I'll go to the field.
Oh, that's about time.
Such joy, such joy. I have to get another thing to get energy for that.
We need to worry about these things.
Worry about different things.
Yeah. The parents and their kids.
All right, guys. Have a good day.
I went to bed at 12 last night and I want to pay.
I'm convinced the less I see them, the more excited I am. No. Maybe it's because I'm excited to speak.
Last night, I pulled it all nice now.
Use glass there. Over here doesn't need to flatten out. So nice change in the
Everything is flattens out, yeah. But I wouldn't mark that wrong. Yeah, it does, and it has a bit of a kink.
Okay. And then there's this, okay.
Perfect.
Oh, I switched.
You got it?
You can switch if you want to.
What are these? Ooh,
Does anyone know if Abigail, he did it Wednesday, Abigail.
delicious. Your mom's a genius. Tell her I said that.
Wait, what's the other, the last one? Yeah?
Bye, guys.
Well.